Guys, let's get started with Unit 4. So CPC-TC, that stands for corresponding parts of congruent triangles are congruent. Remember, that's when we're using angle, angle, side, side, angle, side, and all of those wonderful ones. You've got to prove the triangles are congruent first, and then you can say their parts, like their angles or their sides are congruent. In this one below, I want to point out that these say that they're congruent, which means it's an isosceles triangle, which means these two base angles are going to be equal. So to solve for y, you can say that that angle is equal to 3y, and I would just add these three angles together. I would get 8y equals 180 degrees, because the angles of a triangle, the angles where the bends are, where the angles are, is 180 degrees when you add them together. So divide by 8 and divide by 8, and you would get y equals 22.5. 22.5. Okay, still getting the hang of this iPad. Next up, because they're marked as congruent, you know that these two sides here equal each other. So I'm going to just go ahead and do 7x minus 2 equals 3x plus 4. All right, so I'm going to combine. I'm going to subtract 3x and 3x, and I'm going to get 4x. And then I'm going to add 2, and I'm going to add 2 equals 16. I'll divide by 4 and divide by 4 and get x equals 4. Okay, next up, oops, sorry guys. Just wanted to make sure I am, I need to turn my texts off so that they're just not showing you all the writing. Sorry about that, guys. I'll get the hang of this soon. Okay, so anyhow, next up, this would be these two angles, angle A and angle D. They add up to this angle right here, if you remember. It's called the exterior angle theorem. So ADE, from A down to D over to E, that's this angle, is 2x. This angle, D from DAE, this angle right here, is 4x. 4x minus 6. And then AEG always reminds me of Agamemnon. Anyway, it is 5x minus 2. Okay, so what we're going to do is we're going to add this angle and set it equal to this angle right here. So I'm going to add my 2x and my 4x. I'm going to get 6x minus 6 equals 5x minus 2. Okay, so I'm going to subtract 5x, cross that off, subtract 5x. I'm going to end up with x, and now I'm going to add 6 and add 6. X is going to be equal to 4, because negative 2 plus 6 is 4. So 4. I'm going to try to make this a little thicker. Let's try that. Okay, now it says use the figure below to solve for x. So again, these show us that this is an isosceles triangle, which means these base angles are equal. So I'm going to do 2x equals 3x minus 18. All right, I'm going to subtract 3x, subtract 3x. I'm going to get negative 1x equals negative 18. And I'll divide by that negative 1 and divide by that negative 1 so that I get x equals 18. And now I'm going to scroll on down here, and it says use the figure below to solve for x. Well, because it shows me, hey, these two angles are equal, I know it's an isosceles triangle, which means I know those two sides are equal. Kind of confusing, huh? So what I'm going to do is I'm going to ignore this 4x plus 1, and I'm just going to do 5x minus 8 equals 2x plus 10. Minus 2x, and get 3x minus 8 equals 10. Then I'll add that 8, and I'll add that 8 to the other side of this equal sign and get 3x equals 18. Divide by 3, and x equals 6. Right, forgive me while I erase for a second, just so I don't cut into this other one. But what I'm going to do here is I'm going to go ahead, and I know that all three of these angles are going to add up to 180. So I'm going to just think of like taking this 90 out. So by 90, and I'll be left with these two angles are going to have to add to 90. So it's going to be x plus 19 plus 2x plus 11 equals 90. Because a triangle is 180, right? And if I subtract this 90 from it, I end up with 90. So I know these two angles are going to sum to 90. So I'm going to end up combining like terms and getting 3x plus 30 equals 90. I'll subtract 30 from both sides, and I'll get 3x equals 60, and then my x is going to equal 20 when I divide both sides by 3. Okay, next up, well, if this is 60 and this is 60, this triangle, that angle right here, has no choice but to be 60 degrees, which means that's an equilateral triangle that all the sides are congruent. So what I'm going to do is I'm just going to go ahead and set these equal to each other. I'm going to do 11x minus 89 equals 7x plus 19. Well, I'll subtract 7x from both sides, and I'll end up with 4x minus 89 equals 19. Then I'll add 89 and add 89, and I'll get 4x equals 108. When I divide by 4, I will get x equals 27. Okay, and then down here, because these are marked congruent, I know that all these angles are also going to be congruent, which means they all have to be 60 degrees, right? Because the three angles of a triangle must add up to 180. And if they're all equal, 60 is the only number that would do that. So we're going to do 4x plus 8 equals 60 degrees. I'm going to subtract 8 and get 4x equals 52. And divide by 4 and get x equals 13. Okay, here, part of my erasing for a second. Okay, here I see that, let's use some colors. A and F, they correspond. And B and G, they correspond. And C and H, they correspond. So when it starts with G, H, F, I look back here and I see, oh, G was in the middle and that was matched with B. So I'm going to write triangle B. And then I look and I see, oh, H. Okay, H was marked with purple and that went with C. So I'm going to say C. And then last but not least, F matches with A. So BCA, triangle BCA. Okay, this is also kind of the same idea. So R and T, I'm going to just go ahead and put a circle around R and a circle around T, and W and U, which means I know that U is 90 degrees since W was 90 degrees. And then lastly, S and V. So let's just put a dot by S and a dot by V. All right, not going to jump around too many colors right now. So basically we want to find the values of x and y. Well, if you notice here, I can figure out the measure of angle t, and I can do that. Angle t I can find by going 180, minusing the 90, this 90 right here, minusing the 29, and it will give me 61 degrees. So I'll know this angle is 61 degrees. Well, in order to solve for x, I can see that r and t, they are the corresponding angles. So I'm going to do 8x minus 27 equals 61. All right, I'm going to add 27 and add 27 and get 8x equals 88. Divide by 8, divide by 8, and get x equals 11. So then for y, I'm going to try to see what matches up, and I can see that 25 here, I'll go ahead and switch colors for y. 25 here and 3y, they're both directly across from my 90-degree angles. They're also between a dot and a circle. So to solve for y, I'm going to just do 3y plus 7 equals 25. I'll subtract 7 and subtract 7 and get 3y equals 18. I'll divide by 3 and divide by 3 and get y equals 6. Okay, Unit 4 is a long video, so bear with me here. Okay, so it says that AB is equal to CD, so I'm going to go ahead and mark those. It also says that AB and CD, they're parallel. So I'm going to just kind of extend my lines here. All right, so if I know there's parallel lines, then I know a couple other things. I know that these angles are going to be equal. And then because I know this is a shared side, I know that that middle side, that DB and BD side, is going to be congruent. So when I follow it around, I see I have a side, I have this angle, and then another side, and I follow that around. So it's going to be side, angle, side, and now I need to find what matches with A. Well, A and C correspond, so it's going to be triangle C. And then it's B, okay, well, ABD is this triangle right here, and B matches with this angle down here, D, so D, and then I follow it up to my last letter, which is B. Okay, and it says, right here it says RC. It comes through and it bisects this angle, HRT. HRT is this angle, so that means that these two angles are equal. It also tells me that HT, or H and T, are congruent. And then don't forget about shared sides. So if I follow this around, I know I have an angle, and then another side. And I follow it around. So angle, angle, side. Okay, then it says R to T to C. Well, I have to mimic these congruence markers, so it's going to go from R to H to C here. R to H to C. You just have to watch how it's moving and what congruent markers there are and follow those. Okay, here, almost to the end. 3 proofs and we're done, guys. Okay, so here, RP is congruent to PS. So here's RP, here's PS. I'm going to mark those congruent. And then RQ and QS are congruent. Well, one of the things I know, but I don't always necessarily state in the given, is that shared side. So that's congruent. Well, number 1 is given. They told us that RP and PS were congruent. Number 2 is given because they also told us that RQ and QS are congruent. And then it says PQ is congruent to PQ. Well, that's reflexive. All right, so Same thing, looking at the same thing. And as a result, these triangles would be congruent because of side, side, side. Okay, oh, nope, not last but not least, two more. Okay, so XZ bisects angle WXY. So angle WXY is right here. And then YZ comes through and it bisects it, which means that these two angles that I just marked are congruent. It also tells us that WX and YX are congruent. And then hopefully you've been following along and see the shared side. So when I follow this around, I'm going to go ahead and I'm going to mark that that's a side. Here's an angle, and then here's another side. And I follow it around and see that, oh, the triangles are going to be congruent by side, angle, side. Okay, next up, well, this was a given, so I'm going to fill that in. Number 2 is going to be definition of an angle bisector. Well, number 3 was given. And then XZ is congruent to XZ. Well, hopefully you remember from the last proof that it is reflexive. Okay, so notice what's different in proof number 50 compared to 49 and 48. This is asking to prove a part. A part is congruent, so this is a part of a triangle. Which means down here, I'm going to be using CPCTC. And somewhere right up here, right here is where I'm going to say they're congruent by angle, angle, side, or side, angle, side. Okay, so first of all, let's go ahead and mark our two parallel sides. So these are parallel. And then I'll go ahead and mark the other ones in blue so you get a good visual. And these are parallel. Okay, so there's going to be a lot of, parallel line angle relationships here. But let's go ahead and mark this up as given. Oops. All right, and then it says alternate interior angles. Well, the alternate interior angle that I chose was RQS, which is right, oh, here, I'll use this pink, which is right here. And it's congruent with angle PQS. So let's go ahead and write that. I'll jump back to blue. Angle RSQ is congruent to angle PQS. All right, and then it tells us QR and PS are parallel, so that's given. And then it jumps down here, and I'll use orange this time, and says that RQS, oh shoot, I did the wrong ones last time. Well, kind of think flip-flopping them. They would be alternate interior angles as well. Alternate interior angles. All right, and reflexive, I hope you're remembering the shared side. So that would be QS. Oops, let me jump back pens here. QS is congruent to QS. Then if I follow this around, I have an angle, then I have a side, and then I have another angle. So the triangles are congruent by angle, side, angle. All right, and when we match up the corresponding parts, Q corresponds to S, P corresponds to R, and the other S, well, corresponds to Q because there's some repeats here. And then, of course, it's CPCTC. That's it for Unit 4. Bye, guys.